Okay, this problem's a little long, so if it cuts off, I'll do a second video and finish it, so just be aware. Um, it's a piecewise function, and you can't graph it because you're trying to figure out what B right here and C are supposed to equal. Um, but for the top graph, for x plus 1, you can only use that for x's that are between 1 and 11, but don't include 1 and 11. And then on the other one, for the x squared plus bx plus c, you can use these x's, which looks confusing, but if you have the absolute value of x minus 6 being greater than or equal to 5, that means that x minus 6 is either greater than or equal to 5, or the x minus 6 is less than or equal to a negative 5. That's how absolute values work. And then if you add 6 to both sides to solve this one, this would be all x's greater than or equal to 11. All right, so that's that. But you also have, if you add 6 here, x is less than or equal to 1. So basically, just to give you a visual on this, here's a number line. Here's 1, and somewhere up here is 11. So if you're going to use the quadratic equation, it would be for these including 1 and also 1 and those. But if you're using the linear function, you can only use it for x's in between here. Now this is just a number line graph representing all the numbers that x can be. So any number x that's between 1 and 11, you'd have to use the linear function. But if you want any x's less than or equal to 1 or greater than or equal to 11, you got to go with that. Okay. Anyway, we are trying to figure out what B, let's see, determine the values of B and C such the following function is continuous on the entire real number. What did I do? I went with, you can either use the 1 or the 11. I don't think it matters which, but since 1 is a smaller number and easy to work with, I'm going to go with that one. And I want to see what the function is doing from the left and from the right. I think that's how I was thinking that. Yes, okay. So I need some space here. I want to find the limit as x approaches 1 from the left, and that would be coming from this direction. So I would need to use the x squared plus bx plus c function for that. And since it's coming from the left, you're simply going to plug in the 1 and see what happens. So I would have 1 squared plus b times 1 plus c. Let me erase this stuff to get it out of my face. Let me erase this too, make some more space. And then of course this would simplify to be 1 plus b plus c, and just going to leave that at that. Okay. Then you want to look at the limit as x approaches 1, but from the positive side, and that was the pink one, right? Because you're approaching it from this x going this way towards the 1. So I'm going to use the x plus 1, plug the 1 in there. 1 plus 1 is 2. So if this is continuous, then that means that the limit approaching from the left should equal the limit approaching from the right. So if I take this guy and this, and this guy, because that's what they simplified to be, and set them equal to each other, I'm going to have the 1 plus b plus c equals 2. And then if I subtract 1 on both sides, I get B plus C equals 1. And I'm just going to put a box around that for right now. Okay, now what you need to do is, okay, I do need to do the other end, sorry. So I do have to do the 11. I am now going to do the 11. All right, and to make this easy on myself, I'm just going to erase all this. Sorry. And now we're going to approach 11 from the left. And if you remember my number line, here was 1, here was 11. The pink was, the pink was here, and the, come on yellow, the yellow was there. So if we're approaching it from the left, that would be the pink. So I would be using the x plus, oh my gosh, I would be using the x plus 1 this time on that. And so that's going to be, sorry I keep goofing up, 11 plus 1, which would be 12. And then if you approach 11 from the right, that's the yellow, because you're coming from this direction now towards the 11. And so it's the x squared plus bx plus c. So that's going to be 11 squared plus b times 11 plus c, which would be 121 plus 11b plus c. So now what I'm going to do is take this and set it equal to that. So the 121 plus 11b plus c equals the 12, and if I subtract 121 from both sides, I get 11b plus c equals negative 109. And what I now have is a system of equations. So I have to solve these two by any kind of method. Usually it's like substitution or elimination. I'm going to use elimination. If I were to take this equation and multiply it times negative 1, that would give me negative b minus c equals negative 1. And if you add these two equations together, you get 10b. Those cancel out, and you get negative 110. And then solving for b, negative 110 divided by 10 is negative 11. So b would be negative 11. And then I would come back over here to the blue one and stick negative 11 here and say negative 11 plus c equals 1. And I would add 11 to both sides, and I get 12. And there's my answers. B is negative 11. B is negative 11, and C is 12. And I'm going to go back to Mobius, and I already typed those in. Negative B is negative 11, and C is 12. And they actually used substitution down here. I used elimination, but they both work. I mean, heck, you could even use your graphing calculator and like solve either equation, solve them both for their B's or both for their C's and find the intersection point. But sometimes doing that takes a little longer than doing it algebraically. But that one was not that much fun. But that's how I did it, and I hope that makes sense, and I'm sorry if I made too many scribbles.